Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 4 of lesson number 8, motion. So now if you remember, like starting from part 1 till part 3, we have discussed so many important parts related to motion, right? And motion is something which keeps the object around you moving. Motion, like the other word that we can use for motion, is movement. Okay, so now we have studied what is motion. You have understood that by relating it to real life examples, like, right? And the picture that you can see on screen, that is also a kind of motion of the planet around the sun, right? So we have understood like motion in detail in like part 2. In part 1 was the introductory part where we have discussed on certain important terms which you should be knowing before I start the lesson. But nonetheless, we are going to discuss again. Like we had discussed about velocity, acceleration, then average speed, what is speed. And now if you know, like we even discussed on in the last part, we discussed on calculating the average speed, right? So it's like distance traveled upon, like we calculated that and we even saw one example through that. And you know, like this lesson is has many solved examples which have been given. It means there are many numericals which can come in exam as well. Now as you are in class 9, you will feel like while you study physics, you will feel like you're studying maths only, because you'll have numericals over here as well, where you will have to use certain formulas, and you will have to calculate, you'll have to convert the like meters into kilometers, hours into seconds, and there are so many things. So many of the students, because of this, they find science to be very difficult. But I will suggest, please don't. Okay, it's all easy. You have to keep this thought in your mind that it's easy. It's just that you need to know the proper formula and you have to apply it properly. And you're done with it. Okay, so make sure that you're not getting scared with any of the numerical. Like at the end, it's a numerical itself, right? And there is a solution to all the problem that comes, right? So you will be able to tackle that as well. Don't worry about that. And make sure whatever real life examples that we are discussing, or the activities that they have given, if possible, you try and do it by yourself. You perform it by yourself. If all the requirements you have, like if the materials needed or the required materials are there with you, make sure you have them. Okay, and one more thing you should be knowing, like if there's an activity we have discussed, you should be knowing the observation, explanation and conclusion part for that. Okay, so make sure you know that as well. So now I want each one of you to please revise whatever we have studied so far. I hope every one of you are going through it. You have to revise each and everything that you have written in your book, starting from the basic definition to the things that we have discussed. Okay? So I'm going to show you the slides one by one, and I want each one of you to please go through the slide and just revise if you have missed out something in your book, like you should be knowing that as well, right? So we have started the lesson by discussing about describing the motion itself along with the examples which have been given, right? So I just want each one of you to please go through it quickly. I hope everyone is going to this slide. After this, like describing motion, we discussed on motion along a straight line. So I want each one of you to please go through it quickly. After this, like as I told you, we discussed on this motion along a straight line. So I want each one of you to please go through it quickly. So the example given over here is like very easy and very informative as well, which is going to help you to understand how a motion along a straight line actually occurs, right? After this, we discussed on this activity, and as I told you that you should be knowing the observation, explanation, and conclusion to it, right? So I want each one of you to please go through it quickly. I hope everyone is like going through the activity and you're letting yourself know the observation explanation to it. You have to explain it to yourself as like I'm not listening to y'all, right? So don't think that how will you revise it. Just be true to yourself, and that is what I need from y'all. Okay? After this, we discussed on this activity 8.2. So I want you all to please go through it as well. Now, this was the easiest activity, I guess. So I hope you all know it. After this, we discussed on uniform and non-uniform motion. So I just want you all to please go through it. Then we discussed on this activity 3.8. So 8.3, so I just want you all to please go through it as well. After this, we discussed on measuring the rate of motion. So I want you all to please go through it as well. I hope everyone is going through it because this is an important slide where we have the SI unit and everything which has been mentioned, right? So just go through it, everyone. So sorry. After this, we discussed on the formula for calculating the average speed, and it's like average speed is equal to total distance traveled upon total time taken. Okay, so if the object travels a distance s, total distance traveled is s, and total time taken is t. So average speed is, like, you can say, denoted as v. So the formula becomes v is equal to s upon t, right? After this, we discussed on this example, like how exactly we can, you can say, calculate the average speed with the information given, right? So I hope every one of you are going through this example. After this, we discussed on speed with direction. We didn't discuss, right? We need to discuss it today, like speed with direction, right? So see, the rate of motion of an object can be more comprehensive if we specify its direction of motion along with its speed. Now, when it comes to like the rate of motion of object, it's going to be comprehensive if we are going to specify its direction along with its speed. Because if you just want to know the motion of the object, that is a different thing. But knowing the motion of the object along with the speed is different, right? So the quantity that specifies both this aspect, we know that quantity as velocity. What do we call it as? Velocity. So velocity is the speed of an object moving in a definite direction. Now motion of object is moving object, right? But when it moves in a definite direction along with a speed, along with a definite speed, that becomes the velocity. And that is why velocity is defined as speed of an object moving in a definite direction. What is velocity? Speed of an object moving in a definite direction. So velocity of an object can be uniform or it can be variable. Uniform means it can be same throughout, or it can be variable means it can keep on changing as well, right? So it can be changed by changing the object speed. Now as they stated that the velocity of the object, it can either be uniform or it can be different, variable, right? Now if we are changing it, if the velocity of the object is changing, how is it so? So if we are changing the speed of the object or the direction of the motion, or if we are changing both, then we can say that the velocity has changed or the velocity is varied. Okay, so see what they have explained further. When an object is moving along a straight line at a variable speed means different speed. The vehicle is moving in a straight line, but the speed differs. Like in the starting it slows down, then it's very fast, then again it slows down, right? So we can express the magnitude of its rate of motion in terms of average velocity. So in this case, if we have to come up with the magnitude of its rate of motion, then we have to calculate its average velocity. So we are going to calculate the average velocity same as we calculated the average speed. Now average, for calculating the average speed, we had the formula as total distance traveled upon total time taken. This is the formula for average speed, right? And the formula for average velocity becomes as initial velocity plus final velocity divided by 2. But if you see, there's one more point given. In case the velocity of the object is changing at a uniform rate, what is happening over here? Velocity of the object is changing and that is happening at a uniform rate, then the average velocity is given by the arithmetic mean of initial velocity and final velocity for a given period of time. And over here we get the formula for average velocity as initial velocity plus final velocity divided by 2. What is the formula? Average velocity is equal to initial velocity plus final velocity divided by 2, and mathematically if we have to write it, it becomes VW. Average speed is VW, initial velocity is represented as U, final velocity is represented as V, so it becomes U plus V divided by 2. Now you have one formula over here as 8.1, that is V is equal to S upon T. V is the average speed, so average speed is equal to distance traveled, that is S, upon time taken is T. So V is equal to S upon T, right? And over here we have the average velocity as like VW as U plus V divided by 2. Okay. So you should be knowing this. So this is the other formula for V that you get. So where V average velocity is the VAV is the average velocity, U is the initial velocity, V is the final velocity of the object. And over here the speed and velocity has the same unit. What will they have? They will have the same unit, that is meter per second. Okay. So I want you all to please write all the important points from here, from the screen. I hope everyone is writing all the important points from screen with respect to speed, with direction. I hope everyone is writing all the important points. You have to write the formulas as well, and you have to note it as 8.1 and 8.2. Okay. I hope everyone is writing it. Now, after discussing on speed with direction, we have an activity over here to discuss where we need to measure the time it takes you to walk from your house to your bus stop or to the school. And if you consider that your average walking speed is 4 km per hour, estimate the distance of the bus stop or the school from your house. So like it's a numerical based kind of activity, so you have to calculate the distance of the bus stop or the school using the formula that we have started, right? So I just want you all to try this with a proper formula and let me know what will be the answer for this. So over here if you calculate, like we know speed, the formula for speed is distance traveled upon time taken to travel that distance, right? So speed is distance traveled in a unit time, and here it has been given in kilometer per hour. So we need to calculate the walking time in hour, right? So for example, if it takes 12 minutes to reach school, then the time in hours will be 12 divided by 60 and it will be equal to 0.20 hour, right? And now you know, if you have to calculate the distance, the formula for distance will become speed multiplied by time. So you know the speed is 4 km per hour and time you took is 0.20, right? Because it takes 12 minutes. So when you divide 12 by 60, the answer that you get is 0.20. So 4 km per hour multiplied by 0.20 hour, and when you do this you get the answer as 0.8 kilometer or 800 meters. Okay. Now over here we can also convert kilometer per hour speed to meter per minute or meter per minute. Okay, so in all the case the answers will be same, but the precaution to take is time should also be in the same unit. Whatever time that we are taking, like as we divided 12 minutes by 60, right? So that we get like an hour, right? So that is the precaution that we need to follow, that the time taken should be in the same unit, and for a shorter distance or small walk time we should prefer meter per minute. Okay, always keep this thing in your mind. I hope you all are like writing this activity quickly. Now after this we have one more activity over here. See, at a time when it is cloudy, there may be frequent thunders and lightning, right? And the sound of thunder takes some times to reach you after you see the lightning, right? So can you answer why this happens, and can you measure this time interval using a digital wristwatch or a stopwatch? And if you can, calculate the distance of the nearest point of lightning over here. You need to consider the speed of sound in air, and that is going to be equal to 346 meter per second. Okay, so see what you can write over here, the gap between thunder and lightning, like we need to calculate that, right? So over here, the friction between two clouds result in thunder and lightning. Whenever two clouds, they have a friction together, it results in thunder and lightning, and both the process happens simultaneously. Okay, the thundering and lightning occurs simultaneously, but the speed of light is very high, and it can be like 3 lakhs kilometer per second, while that of sound and air is 346 per meter per second, right? So as a result, we see that we see the lightning almost instantaneously, while it takes time for thunder sound to come near our ears. It's all because of the speed. Okay, so now the question is, how can we measure the distance of nearby lightning then? So we can calculate the gap between the lightning and thunder sound, because we know that lightning is almost instantaneous, right? So it will mark as start for the journey of sound, and the gap is the time taken to travel and come near our ear. So with the velocity of the sound given, we can calculate the distance by using the formula as distance is equal to speed into time. We know the speed of sound in air is 346, right? And if, because we know that the gap between thunder and lightning is 6 seconds, right? So 346 into 6, right? And when you multiply 346 multiplied by 6, you get the answer as 2076 meters. What will be the answer that you will get? 2076 meters. Okay, and note one thing, that the time gap, it depends on the distance between the ground and the cloud. Okay, the time gaps depends on what? The distance between the ground and the cloud. So when you go in hilly areas which have high altitude, the time gap can be very less. In hilly areas, the time gap will be very less. It can be less than 1 second as well. Okay, so the time gap is can change with the space. Okay, so I want you all to explain this in your own words quickly. I hope everyone is explaining it in your book. After this, like we have this example 8.2 to discuss. So see, the odometer of a car reached 2000 kilometer at the start of a trip and 2400 kilometer at the end of the trip. Okay, so if the trip took 8 hours, calculate the average speed of the car in kilometers per hour and meter per second. Okay, now here they have given distance covered by the car, that is S is equal to 2400 kilometer, right? What is the distance covered by the car? It's 2400 kilometer, right? And if we know that 2400 kilometer is at the end of the trip and at the starting it's 2000, right? So what we will do is 2400 minus 2000 becomes equal to 400 kilometer, right? Now, when the time elapsed is total time taken is 8 hours. And average speed of the car, how do we calculate that? VW is equal to S upon T, right? Distance traveled upon time taken. So distance traveled is 400 kilometer. Time taken is 8 hours. So when you calculate this, you get the answer as 50 kilometer per hour. Okay, now we have to convert that. So what we will do, 50 into kilometer per hour into 1000 meters divide by 1 kilometer divide by 1 hour into 1 hour divide by 3600 seconds. 1000 meter is equal to 1 kilometer, and that is why we are dividing it so that we get the answer in meter per second. So this is how you have to convert kilometer per hour to meter per second, because they have asked you to calculate in both kilometer per hour and meter per second as well, right? So the average speed of the car is 50 kilometer per hour or 13.9 meter per second. Got it? I hope every one of you are going through the example. Now, I hope every one of you have understood it, like how to convert kilometer per hour to meter per second, right? And how to actually calculate the average speed of the car. Okay. Now the next thing that we have is like example again. So see, Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute by swimming from one end to the other and back along the same straight path. Find the average speed and the average velocity of Usha. Okay, what we need to do? We need to find the average speed and the average velocity of Usha. So see what they have given over here. Total distance covered by Usha in 1 minute is 180 meters, right? And the displacement of Usha in 1 meter is 0. Why? Because she is not displacing herself, right? So average speed, we know the formula for that is total distance covered upon total time taken. Now total distance covered is 180 meter and total time taken is 1 minute, right? So we know 1 minute is 60 seconds. So we will multiply that 1 minute divide by 60 seconds. Okay. Then we get the answer as 3 meter per second. Okay. And this is how we calculate the average speed. Now average velocity is equal to displacement upon time taken. Displacement is 0 meter and time taken is 60 seconds, right? So the average velocity over here will be equal to 0 meter per second. Okay. Then after that, the average speed of Usha is 3 meter per second and the average velocity is 0 per second. Got it? Now after this, rate of change of velocity, I'm not going to start with this today. I will be starting this in the next part, but make sure whatever we discussed with respect to speed and its direction, you're very much clear with it. Okay, so we will be starting with rate of change of velocity in the next class, where we will be even discussing on acceleration. What exactly acceleration is? It is change in velocity upon time taken, right? And after acceleration, we had this activity 8.6 that we will be discussing on in detail. After this, we again have one example to discuss, which we will be discussing over here. And through this example, you will know like how to calculate the acceleration. Okay, because calculating acceleration, average speed, average velocity is very important. These are some important numericals like that they are going to ask you. The questions will differ, but at the end you have to calculate this only. Like you will have to calculate either acceleration, average speed, average velocity, these things only, right? Then after that we will discuss on graphical representation of motion in detail. Okay, then after graphical representation of motion, we have distance time graph to discuss, which we will discuss in detail again. Now these graphs are very important. So one we have is distance time graph, then we have velocity time graph. After velocity time graph, we have activity 8.7 to discuss. Okay, here we need to plot the graphs as well if possible. Then we have activity 8.8. After this, we will be discussing on equation of motion by graphical method. How can we represent the equation of motion by graphical method? We'll be discussing on that. Then after that, we have equation for velocity time relationship to discuss. We will discuss on that as well. Then equation for position time relation. Like first we have equation for velocity time relation, then we have equation for position time relation. After that we have equation for position velocity relation, and lastly we have this example 8.5 and 8.6, 8.7, which we will be discussing. Now if you can see in 8.5, we will be finding the acceleration, and second thing will be the distance traveled by the train for attaining this velocity. So this is what we will be finding. Then example 8.6, over here we will be calculating acceleration, and the other thing that we are going to calculate is distance covered by the car in that time. Okay, so we'll calculate this. Then in example 8.7, we will be calculating the distance it traveled during this time. In short, we will be calculating the distance over here. Okay, and then we will be discussing on uniform circular motion in detail, what exactly it is, using along with the formula. Then we will be discussing on activity 8.9 in detail. Okay, then after this we have the summary discussion to discuss, like what exactly we have studied till now in the lesson. We will be discussing all of that, and after that we have few exercise question to discuss, which I'm going to show you one by one. So I want each one of you to please go through it quickly. I hope every one of you are going through the questions. So this is how we will be ending up with the lesson motion. And I hope whatever we discussed today in this part for the lesson motion, each one of you are very clear with it. Okay. Now whatever has been left, the rest of the part I will be continuing in the next part. Thank you everyone.